Welcome back. The next section is section 3.2, which we will be talking about mutually exclusive events. So A and B are mutually exclusive events if they cannot occur at the same time. So the key word is the two events cannot occur at the same time. That is, the probability of A and B happening together is a big absolute zero. So once again, mutually exclusive events are two events that cannot occur at the same time. Now let me give you an example. If I am talking about, let's say, what about you roll a dice, right? You roll a dice. Oh, never mind. Let me move it. You roll a dice and you look for a number. So if you roll the dice and I ask you, what did you get? You either say it's 2, 3, 4, 5, or 6, or 1, right? But is it possible to get 2 and 3? No. Is it possible to get 1 and 6? No. So what does that mean? These are mutually exclusive events. If one happens, the other one just cannot occur. Can it rain and not rain? No, only one of them can happen. If one happens, the other one cannot. It can either rain or it cannot rain. Now the next one is, can you be inside the house and outside the house at the same time? Not possible. Either you're inside or you're outside. So both of the events cannot occur at the same time. Now let's go ahead and look at some of the examples. All right, before we move on, the key terms for this topic are mutually exclusive, that two events cannot occur at the same time. And events that are mutually exclusive are called disjoint events. That means they are not together. They don't share anything. They don't have anything in common. They're totally disjoint. Keep in mind, they don't share anything. That means they don't have anything in common. And they're just separate. One happens, the other one cannot happen at the same time. Let's go ahead and take a look at this example. Each dot outside the Venn diagram below represents a student in a particular major. The red dots represent mathematics major, abbreviated MM, and the blue dots represent economics major, abbreviated EM. So let's go ahead and begin. Let A be the event that students are currently enrolled in a writing course. B is the event that students are currently enrolled in a statistic course. So what are they asking us to do? They say first arrange the dots on the Venn diagram so that the following situation is represented. Both mathematics majors are enrolled in statistics course. Keep in mind, when they say they're enrolled in statistics course, they are not talking anything about the writing course. So if they say they are in statistics and writing, that's a whole different story. But when they say they are just in statistics, you're going to go ahead and put them just in statistics. So let's go ahead and do that first. MM4, MM5. So MM4 is in statistics, MM5 is in statistics. You see what I'm doing? I cannot put them here. When I put them here, that means I'm putting them in writing and statistics course. But I don't know that. They only said statistics. I'm only going to put them in stats course. All right, now let's go ahead and see the next one. Two economic majors are enrolled in a writing course. EM1 and EM2, okay? EM1 goes in the writing, EM2 goes in the writing. Keep in mind, I cannot put them here because I don't know if this EM2 is in writing and statistic. I know it's only in writing, so I'm going to keep it there. Now, one economic major, EM3, is not enrolled in statistics or in writing. So this guy is neither statistics nor writing, so he's outside. Now let's go ahead and see what the question is. Use the diagram to determine whether the following statement is true or false. 5 friends, 2 mathematics, and 3 economic majors are enrolled in writing and statistic course. But mathematics and economics majors don't take classes together. So A and B are mutually exclusive. Again, keep in mind when they say mutually exclusive, the common terminology that you should be thinking about is something that is in common. Oops, that's not how I spell common. Something that is in common. They are sharing, right? And cannot happen at the same time. Cannot happen at the same time. Now, if I look into it, they don't have anything in common, right? They have nothing in common. You see this common portion? There's nothing in here. They're not sharing anything. So there's nothing in common. They're not sharing. And I can either take a writing course or I can either take a statistics course. I cannot take both of them at the same time. So this cannot happen at the same time either. So it satisfies all my conditions. So they are mutually exclusive. All right. Let's go ahead and look at the next problem. Pregnant women has an option of being scanned for cystic fibrosis risk in their unborn babies. If a mother or a father have a certain recessive gene, the baby is at risk for cystic fibrosis. Now, every time you are talking about mutually exclusive or not, you have to take a step back and think about those three words: common, share, and it cannot happen. Now, if I think logically, if the mother or the father has the recessive gene, there is a possibility that the baby is going to be at risk for cystic fibrosis. So, not happening is not true. And what are both of them sharing? They're sharing the common risk of the cystic fibrosis. Now, keeping that in mind, let's go ahead and read what the options are. Now, what are they saying? They are saying that event A, the mother or the father carry the recessive gene. Okay, so very good. Event A is the mother or the father carry the gene. Event B is the father carries the recessive gene. Event C, the baby is at risk. So if you see event C, it says the baby is at risk for the cystic fibrosis. All right, so event A, event B, the mother or the father carries the gene. Event B is the father carries the gene. Event C, that the baby is at risk for fibrosis. No matter how I take, I somehow see that the baby is going to have cystic fibrosis because the chance that the mother or the father has it, and it's telling me that the father does carry the recessive gene, somehow concludes that the baby has a risk. Now let's go ahead and take a look. Event A and B are mutually exclusive, that they're saying if the father has it, the mother cannot have it. Now, that's not true. Event B, if the father carries the gene, the baby cannot have the gene. No, that's not true. If the father carries, the baby is going to have. And let's look at event A. And they're saying they're mutually exclusive. Remember, mutually exclusive tells me that if one happens, the other one cannot happen. So if the mother has it, then the father cannot have it. No, that's not true. It's a mother or the father can have it. If the father has it, the baby cannot get it. That's not true. So event A is the mother having the gene. Event C is the baby at risk of cystic fibrosis. They're saying that they're not mutually exclusive. That is correct. So when the mother has it, the baby might have it. There is a chance that the baby might have that gene as well, cystic fibrosis as well. So they are not mutually exclusive. All right. So this is going to be your option. All right. A card is drawn from a standard deck of cards. Remember, the deck of cards has four suites: the club, the diamond, the heart, and spade. Each suite has 13 cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Given three events, which of the following statement is true? Before I go ahead and do that, let me go ahead and pull up a picture of deck of cards. There you go. I have 1, 2, 3, 4 ace, 4 twos, 4 threes, and you see each of them has a diamond, spade, club, and heart. All right, going back to the problem. Event B and C are mutually exclusive. Let's go ahead and see. Event A is drawing a club. All right, so Event A is drawing a club. So let me go ahead and draw a club. All right, let me see if I can do that. All right, event B is drawing a spade. Oh God. All right, guys, there you go, spade. Event C is drawing a queen. Well, I'm just gonna put a Q. All right, so let's go ahead and see how this is possible. So to do that, let me go ahead and move on to the deck of cards. I have my deck of cards, so let's go back and look at event A is drawing clubs. Event B is drawing spade. Event C is drawing a queen. So I'm going to go back to my deck of cards here. Event A is drawing a club. So what I'm going to do is I'm going to go ahead and highlight all the clubs here. So these are all the clubs that I'm going to pick. Event A is drawing a club. So I'm going to go ahead and highlight all the clubs. There you go. I think I forgot, event B is drawing a spade. So these are all the spades. And event C is picking a queen. I'm going to change the color here. So these are all the queens right here. All right. So as you can see, when I'm picking a club, there's no way I can pick a spade because it could be just a club or a spade. It cannot be both club and a spade. But when it comes to queen, I can have a queen and a club. I can have queen and a spade. Do you see that? But when it comes to clubs, it's either clubs or spades. Now, once we know that, let's go back to the problem. All right, so what do we have? What are my options here? My options are telling me that event B and event C. What is B? So remember what we talked about. I can have a queen with spade. I'm just going to write spade. I'm not going to attempt to draw it. I can have a queen with club, right? So he's saying B and C are mutually exclusive. No, that's not possible. I can't have both of them together. But A and B are mutually exclusive. Yes, they are. I cannot have a spade and a club. So technically, this is my right answer, right? But let me go ahead and see if I have more right answers. Event A and C. So he's telling me that are not mutually exclusive. That means he's telling me I can draw a queen and club. Yes, that is also true. So yes, this is also true. Event A and C are mutually exclusive. No, this cannot be true because we already told you that they are not mutually exclusive. So these are your answers. When you're doing a problem like this, please make sure you read them more than once so you understand the concept.